All right, yo, let's get it. Cool. Well, I don't even have anything to make right now. Hold on. Okay. Where were we? KO. So. Yeah, so we had static member variables. What would be a good case? Something that they all share. Oh, I'm thinking about like complex AI where. Oh, actually, we could have like let's picture a group of little animals that in a game can all be scared, but they all have their own independent behavior. But as a group, their frighten meter can increase, which makes their behavior more erratic and more something like that. So we'll make a little program. Do I even need that? I don't think so. Class, we're gonna call it we're gonna call them imps. And the imps have a health. They have speed and and maybe they also have a double frightened. Okay. And then they have a default constructor. And then they have a normal constructor. Okay. And we could have a, let's see. Or we could say there's a frighten function. And what it does is flee with speed. Well, let's see. Actually, what we do is we just set m speed is itself times a static double group frightened. Fuck, but it has to be const. I accidentally did insert. Which one is insert? There it is. Okay. I forget that it doesn't have to be. Oh wait, hold. It just needs to be defined outside. Cool. Okay, so it's still one. All right, fine. I forgot that it only gives compiler errors first, and it gives linker errors after if there's if everything compiles properly. Because they're two separate steps. Compile then link. So we avoid frighten, it doesn't take anything, and it uses group frightened, and then we could have a function that is what's the type? Static double. Oh wait, yeah, we don't specify static here. Or we... We started at 0 maybe. Excuse me. Actually, hold on. Oh, yeah, this does. Okay, this is our setter. I'd rather just be set. Okay, so we create a bunch of imps. They all have their different health and individual speed and individual frightened level, different temperament. We create them and we usually give them a health, a speed, and a frightened, or they get their default values, whatever. 25 health, 32 speed, and 0 frightened. They don't spawn frightened. Maybe they're a little flighty, maybe they're a little like 3, they're just always whatever. And then you could frighten them, so when you walk past, called when player walks past, their temp speed, their current speed, save current speed. Okay. I save the speed, and then they go a little bit quicker when you run around, so they're like this. Then they're moving around, and then they're still moving around, kind of, and then they go back to normal after. And we can set the group frighten to a specific amount depending on what happens in the environment. So, environment updates how frightened imps are. Maybe a calm biome has this value set to be low, and let's see, actually, and this should just be. This should honestly just be that. And we set the group frighten to be this, and we could maybe increment it over time, but this is how we just set it. And maybe when we spawn them, we actually set them, we initialize them with group frightened. And then we could even have a default argument called group frightened. So that if we omit frightened, they get group frightened. If they specify nothing, they get group frightened. And whatnot. So, and really, if this is the case, then it should just be multiplying their speed by what I mean. At this point, regular frightened is kind of moot. I mean, we don't even touch it. So, I mean, honestly, I'd rather just do that. But cool, little example. I'm thinking this is like a case for like a Little Nightmares game or something. Oh wait, I didn't set how long we would be going for. Hour and 20 longer. 8:47. Okay. Oh yeah, true. And we can access it through the scope. So we could say imp set group frighten, because group frighten is private. So we could do set group frighten to hold 2.0. No. Oh, there it is. Oh, I can't call this because it needs to be called on an actual object. Okay, there it is. That'll do it. And group frighten doesn't implicitly get that. So really, no? Oh. Nice. So we have this group frighten that's defined outside. We have the set group frighten defined outside as well. It's used to update group frighten. Now we can call it and update it for the entire class without having to have it on a specific object, which would be a waste. Create a temporary object just to call the function, just to destroy the object? Oh, nah. Let me look one thing up real quick. Interesting. Okay. Yeah, we declare them inside, we say static, and then outside we don't. Outside we just define. Because it is essentially a global variable, you must define it outside of the class in the global scope. Guess it should have been s underscore 2. Excuse me. Yeah, if I had a class for the game, for a card game, in each round there was a specific value we were changing, it probably makes sense to just change it from main by setting the static instead of having to. Well, I mean, or we could just get the game. We could say, hey, this one game object, and boom. Maybe that makes the most sense actually, because that's the game storing it, and not something applied to multiple different objects. There's only one game object. So one, we're defining it and initializing it, and let's see. One, it defines it, but two, it also gives it value. Cool. There's 0 initialized by default. The definition is not subject, so even though it's public, it could be public or private. Whether we can actually use it is determined by whether it's public or private, because we couldn't use the value by itself. We could only use the set. So the implementation file, okay. Alternatively, it can be defined inline and be placed below the definition in the header for a header-only library. And it needs to be inline. And the reason it needs to be inline, it seems like, is because if we define it once in the CPP file and we declare it in the class, then we're good to go, because the linker will go and say, hey, there's only one copy, we're cool. But if we want it in the header only, well, it's defined in global scope. So every file would be getting it in global scope, which is no good. And it's not const, so it's not implicitly, let's see. Yeah. We make const expression variables inline in order to expose them to the linker. But we make static members inline in order to prevent them, they're already exposed to the linker, to prevent them from yielding a one definition rule and ODR issue. We need to make it inline because if we include it in multiple files, we're basically defining a global variable in multiple files, which means the linker will say, hey, motherfucker, I see this guy, and he's in multiple files. You make it inline to make him okay. So he deduplicates. The class is defined in the CPP file. Static is under the class. Well, yeah. Do not put the static definition in a header file. Yeah, if we're defining, if we're defining it there, then don't include the header. Well, hold. Wait. Yeah. Well, we're saying that don't do that unless you're putting it inline. If you put it inline and put it below, cool. But if the I understand. The point is that it goes where your class is. Is your class defined in a header file? Put the static inline in the header file. Is your class defined in a CPP file? Define it in the CPP file. And then, yeah, right? Let me make sure I remember how to even define these in header files. What about no? Womp. Okay, it's gotta be static. Oh, it doesn't have a fucking type. Oh, yeah, it does go like that. Okay. Can't be static. Okay. Or can't be non-static, sorry. Yes, makes sense. Yeah, because if I'm defining the class in, well, let's see, in a CPP file, I mean, but we normally define classes anyways in a header file and put the implementation in a CPP file. But if we just so happen to do it all in a CPP file, then yeah, don't put it in the header file. I mean, if you did it inline, actually, you wouldn't define it there. You would just define it with the CPP shit. I mean, I guess you could do that. Yeah, so if you define it in a CPP file, and then you just have all the declarations, then... Yeah, I think that makes sense. Okay. For a template class, template is static member. Yeah, makes sense. So like, hold. What? So it was fine here. Trying to find out what was going on there. I don't know why it's cool there. Alright, now what happens if we do... Whoa! Oh! Oh, it needs a template like that to make sure that it's referring to the right thing. I understand now. Okay. And then it can be defined as whatever. I mean... Oh yeah, we can't. That makes sense that we would make this. Mm. Okay. Everything makes sense now. We could put inline still, but we don't need to in the case of a template one. We could initialize it if it's a constant integral type, then it's fine. A static const guy. A static constant. Which means it doesn't need to be defined elsewhere. If it's known at compile time, then it's fine. Okay. I'm not super sure of the value here, but I'll just know that it's a thing. No, wait, hold. Oh, here's the right one. I was on the wrong one. Excuse me. Excuse me. That's because, so in that case, excuse me, are these implicitly inline? Feels like you might want to make it inline, an inline static constant, because otherwise you have an individual copy everywhere, right? And the point is that we want this to be the same everywhere in the whole class. The point here is that this is in the header included with the initialization value, so it's a separate definition. Makes sense. Cool. Yeah, I figured that made sense. So they don't have to be const. They could also be inline. Makes sense, because instead of making it static here and then defining it down below, you could just make it static and inline, so it's included but deduplicated by the linker. Oh, const expression is implicitly in. Are you sure, bro? Members are. Hmm. Make them inline for being unchangeable, or make it const expression without inline needed. Because if you do static const, it isn't guaranteed to deduplicate. If you make it inline, it is. If you make it const expression, it is. Okay. Make static members inline or const expression. So like an easier way of doing that would then just be I kind of like inline static, but sure. Nobody asked for that. All right. What else? Public to set. Sure, we make it 0 by default. Oh, we haven't seen the functions yet. Okay. And we could do this either way. Let's just say 300, and then we could still do. Oh yeah, true. Wait, what? Oh, that's the problem. Oh wait, that's good. I thought we were printing the health for a sec. Yeah, frighten level is 0, and I'm setting Jeff, and I'm checking the frighten level. Or we could do. Same result, we can get them and set them with the class's scope or as a member function. Why use static inside? So we set it to be the generator, and then we increment it. Ah. And really this is grab at the first and then increment. It's not grab the next. It's really grab the current and then make the next. Yeah, I could see that. Guess you could do it either way. You could do MID and then assign it to be the generator and then increment the generator. Or you could assign it to be the ID generator and then increment it in the body. That's probably worse. More readable to me, but it's fine. Makes sense. So we can, if two things have the same value in the array, we can compare their ID. Okay. Ooh, a lookup table, like a const expression value that looks somewhere so that any of them can look at something. Oh, or just actually include the lookup table in the class. I was just thinking store its location as a static so that it isn't overwritten on initialization of new objects. And you make it unchangeable. Usable, but that's all. Only static may use type deduction. Excuse me, if you're a fucking weirdo. Utility has a standard pair T. T in U. So we can make a static object where it is a class object. It must be static to be used in another class for class template argument deduction. Okay. What would this ambiguity be? Oh, meaning ambiguity like for which. So if you had class template argument deduction and you had a class object or an object from a class template in another class, we can't use class template argument deduction for it unless it's a static member, because if it's not a static member and not shared among all and is the same type among all, then it could differ depending on the specific type of object you have. So does that mean... Oh, because this is class template argument deduction. This is not specifying the specific type. Well... we can't do deduction in the class itself. We can do it for the objects where we create an object and it has a different type. But I can't do it in the class itself. And the point is so the types are known between the classes, I think, maybe? Okay. Alright. Not a big generic programming guy, so we'll maybe find out later if I need it. Static member functions now. I gotcha. Because if we created, oh, that's the point of. Well, that's. I was wondering how the hell I was getting the value earlier without instantiating an imp. The answer is a static member function that you can call outside of the class. Because otherwise, you have to create an object. Granted, I was doing a temporary object before, and it wasn't a big issue, but still. You'd need to make sure that the constructor could be empty so you could make a temporary without doing anything. Exactly. We need to do, well, I mean, you could do that in one line, really. Right? Okay, alright, you still can. You don't have to do it in 2 lines. And if that's a temporary, well, actually, it's not a temporary. Never mind, you have a name. Fuck, I'm getting tired. A little advanced section earlier. Advanced said the same. No, this pointer. This should say they can also. Wonder where they're stored, the memory. IRP. Damn, lady, I didn't even realize. Fuck, the sides are not nearly as short as I normally want. I mean, it doesn't matter. It's fine. But for the haircut, I'm used to getting the sides fucking bam all the way down and then faded and little. But the sideburns are just straight up left as is. I'm surprised. Oh, I'm not supposed to be touching my eyes. Let me do the backs. Oh, okay, it's better. All right. Know this pointer. Yep. Makes sense. They can directly access other static members. Oh, so I didn't need to do... Well, and why would I want to do that? I wouldn't want to do this. This is a static guy. We probably don't want to have to call him with a fucking object. We may as well make this be a static. This can no longer be const. And... Oops, what the fuck is happening? And now it's public. Now we can just do mouse get length. Or we can actually just do, yeah, get length. Bum. And they don't have a this pointer, so they can't get a stat. Well, they don't automatically get, let's see. So we could do... Oh, what the fuck is this? Alright. Uh-oh. A non-static member must resolve to an object. There needs to be a something mx. And we could pass it a const mouse reference and call it mouse. And then we're using mouse dot. Well, actually, we can't increment it this time. What's the issue? Oh, here it is. Get length, and then we pass it a mouse, whatever. Okay. Makes sense. Static member is defined outside the class definition, so they can be put in, but they can't have static on the outside. There it is, I see it. So we put static and boom, and then we say ID generator returns this guy. Boom. Inside ID generator, get next ID. Boom. And really, it's not get next ID, it's like iterate the ID. Because the next ID is really, well, I guess get next ID is like get the next one that it's holding. But I don't really like that. I'd rather it be get plus plus. So we could get the current or get the next. Note that we don't use static there. Alright, and the point here is we're saying main. I haven't written a loop in a little bit. Okay. Saying 5 times. The next ID is 1, 2, 3, 4, 5. Yep. Mm-hmm. Oh. Should be made inline. Gotcha. Okay. Same thing for ones outside it. Makes sense. Inline for header files. Okay. A word of warning. I mean, you may as well do a namespace at that point, maybe. Yeah, because if you made another, they would have their own the same shit. They would still share the variable. And if they're static and they're non-const. Unless you make it static const expression, because that's implicitly inline. At least everywhere it's defined, or everywhere it's included. Yep. Instead of writing a class with all static, we have the normal class. We create one instance of it in global scope and change that instance. That way when it's destroyed, it's destroyed. And I guess we have at least one object that we can tie to, and we can make copies of it. It's the same thing, but we can still make copies of it with, we'll hold. Oh, that's the point. So instead of it being a class, we just make a global instance that has the static shit that we need. Yeah, that probably makes the most sense. Yeah. For example, for copying liar's bar, we could have a class. Let's see what the class would be. Would it be the game? The game class? Or game instance class, something like that? And then we could create an instance in global scope. We could also just create a local instance in main. I think it depends. In that case, I don't think it matters. I mean, main's probably best. That way we can follow the control flow. Pure static class versus namespace. Gotcha, because namespaces we access whatever. So putting everything in a namespace versus a static. Means that everything is accessible within the namespace, but if we put it all within a pure static, the static can return a static straight away, but you could have other stuff still. Well, hold. I mean, in this case, we're not using the access controls, though. That's the thing. Well, I mean, you could have it be private, though. You could make static variables that are private and that are returned by the namespace, or returned by the static member function. Okay. I could see arguments for both. Like in a namespace, we could have a variable that we're just changing. But we could also make it so that, yeah, like in the namespace, we can do whatever we want and anybody can change whatever they want. Whereas if we have the pure static, we can still make the static variable private so that we can only access it through the static function. But it can still get the data member, but the data member is still private, so we can't use it otherwise in or outside the class. Which means that there's more control for the static, a pure static class. No static constructors. So we can't make a constructor we can call elsewhere, because doesn't that instantiate an object? A static constructor, huh? What is even the point of that? What would that even be? Like, I get having a class that has things, but having this a static object itself? Or at least an object that has static data members that are initialized. Well, can we initialize it in the constructor? I'm not sure. Oh. 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 Fuck. Okay. The static variable can be directly initialized. Yeah, we don't even have to create the object. Meaning we're saying, oh, here it is. Okay, cool. I was worried for a sec. I didn't know what was going on. This is a static variable. It's inline. It's cool. It's deduplicated. We can include it in a header file. We're good to go. And we're not accessing it by creating an object and then doing myChares. We're just accessing the scope of the class, accessing myChares.third, because I guess that's a thing with characters, and then boom. Excuse me, early is the thing with, oh, well, with a struct. Oh, duh. Never mind. It's just called third. Third is literally the name here. Okay, duh. It's not a function. Why was I thinking that? That was stupid. Hmm. What? And the point here is that in the function we need to exit, or we need to do a loop? So we have a struct called characters, a class that has a character. Or hold. A class with a stat with a hold. A class with a private static function that's defined only in the class. And the point is that when we create the characters, we want to generate it well, I mean, you could just make, well, okay, so the point here is that the struct characters doesn't have a constructor. So instead of making it a non-aggregate, making that class more complicated and then just creating it and having those be the default values, we could have a function that creates one and then updates it, and then we just call that function. That makes sense? Yeah, sure. For example, we have a class called player, and the player has a hand. The hand really, I mean, we might want to make a non-aggregate because maybe we want, maybe not, maybe we just have it a struct. Well, if we say structs are just the ways of storing multiple data members together, then we would make a class. We'd make a class and say, well, if it's a class, then it would be initialized by default, but maybe we could have, if we want to initialize a static, the point here is that we have a static characters. What is something that would be static there? That's the problem. Oh, maybe, there it is. So if we want to create a static, maybe we have player, and player has a static. You could do this in different ways. Let's say there's no game state, there's just different players. And each player in this card game has, well, the player class has a static variable that is the round card. And when we initialize the round card, we want to create the round card. Well, what we do is we create the round card, hold, oh, hold on. So when we have the class, this means that at compile time or at runtime, the static is initialized so it can call all the functions in there. Which means, let's see, or at least it can call a static function because the static function doesn't have to do with any particular object. So the player doesn't even exist yet. We get the round card first. We update it. And let's say that in the class, there's a static function called update round card. And it uses a Mersenne twister to get a random number from 0 to 5 or 0 to 4 so that it's Joker, King, Queen, Jack, King, Queen, Jack, Ace. Yeah. King, Queen, Jack, Ace, Joker. So 0 through 4. 5 cards. Or 1 through 5, either way. But let's say 0 through 4. And it finds that random number. It gets a random number from the Mersenne twister. And then we have, let's say there's another class called card and whatever. It returns that a card with a struct that matches that value. Boom. Okay. Now, or it could implicitly convert to an unscoped enum, or we just do a switch case to make sure. I'd rather be explicit. I'd rather it be explicit, honestly. And then I could just change that function. Okay. And then what happens is we start the game, and we say that we start the game. The round starts, and we get the card to see what the card is. And the card has already been oh yeah, let's say we do that. So like every time we start the game, it's a new, like the game ends every round, or whenever any round ends. So the lifetime of the program spans one game round. So we start the game, boom. It goes in, it instantiates a static object of card, and it is initialized with get random card or get round card. And that is a static function, so it can be called without an object, without a specific object. It creates a Mersenne twister, does all the stuff, gets a random number, and then boom, returns the proper card to initialize that card. So boom, we've called the card and it has been initialized. Boom. In the static function. A lambda. Ooh, random. Here we go. Uh-oh, some stuff going. Oh, hey, we're doing it. Nice. And 7 calls. Nice. Cool. Same best practice, or same practice at least. Show a practical example. This in global random numbers. Oh, yes. That's the point. Yeah. Because we had one for a random number too. Oh, yes, because the example was, well, actually, in that case, it was global scope and it was created to be generated. Well, actually, same thing here. It's static. The point is that the Mersenne twister was created once and seeded once by calling functions that seeded it at compile time, instead of having to do that every time you create the thing. Because it's static. It's only created once. Uno time, uno tiempo. Convert the random namespace in this example to a class with static members. This is great. Perfect example. Nice. Yes, I've made this a bunch of times. These are all included so that they can be deduplicated in the header file. Okie dokie. All right, let's do this. So Okay. And now we have a class called random getter. Sure. Okie doke. We have private. What do we want to do? I guess we could make these guys private, huh? Yeah, why not? Okay. So we're gonna make a static inline function, inline to make it deduplicated, and static to make it callable without any object actually existing. A static inline standard Mersenne twister 109 through 7 returning function called seed empty. It takes nothing. What does it do? It creates a random device called rand. Value initialized. It creates a standard seed sequence called empty seeder, initialized with a couple things. One is a static cast to the standard MTT or 1 through 7 result type. And the things are as follows. One is a standard chrono steady clock dot now dot time since last epoch dot count. Hold. Count. And another is rand, and another is rand, and another is rand. Rand for 4, rand for 5, rand for 6, and rand for 7. So far we're cool. Uh-oh. It's fine. We're not using any of it yet, but it's okay. Line 11. Because we're not using this yet. It's fine. Hold. Wait. Oops. This is wrong. This is the static cast. Boom. And these are the seed values. The issue there was that this entire thing, standard chrono steady clock, now all these numbers were being static casted to 1 and then MT1 or MT1 and 9 through 7, Mersenne twister. The problem there is that we're taking a whole list of numbers and converting it into the result type of this, which is one number. How are we doing that? Well, you can't. So it would be passing it all these numbers and discarding them, and it can't do that. So we take this guy out of the parentheses and put this guy into the parentheses so that it's actually okay. Wait, hold. Hold. Wait. Cedar. Okay, what happened now? Standard chrono steady clock times the big count. And then these are all calls to rand. Okay, I'm not exactly sure what happened. I don't know why those were stuck. Okay. That was kind of scary. And then we return a standard Mersenne twister 109 through 7 seeded with empty seeder. Oh, 1 minute. Okay, and then we create a static inline so it's deduplicated. Yeah, standard MT 109 through 7 called MT initialized with seed MT. And then a function that returns, it's a static function, static inline hold int, right? Yeah, I don't like all these qualifiers first. There we go. What time is the thing? Oh, okay, now we have 1 more minute. Jesus. Oh my, are you kidding me? I'm just waiting for it to go off. I should have just chilled out. All right. Static inline int. All right, fuck it. We'll continue this in a sec. Okay.